Question 17. Table shows some terms of 7. We need to find the value of P, Q, R, S, T, and U. Look at sequence P. We can see that if we minus 2 from 7, we get 5. If we minus 2 from 5, we get 3. So, if we want to find the 8th term, so we need to continue with this operation, where for the 5th term, it is equals to 1 minus 2, which is equals to negative 1. 6th term, negative 1 minus 2, which is equals to negative 3. 7 equals negative 3 minus 2, which is equals to negative 5. And so 8 is equals to negative 5 minus 2, which is negative 7. So the value of P is 7. For sequence Q, you can see that all the terms are cube number. Yes, they are cube number. And 1 equals to 1 cubed, where 1 is actually the n number for the first term. 8 is 2 cubed, and 2 is the n number for the second term. So if we continue with this, if we want to find the value of q, which is the 8th term, so it should be equals to the n number of the 8th term, which is 8 cubed, and the value is equals to 512. So q is 512. For sequence R, we can analyze the fraction according to the position of the digit. If we see the numerator, we can see that the subsequent numerator can be found by adding 1 to the preceding numerator. For instance, 2 plus 1 equals 3, 3 plus 1 equals to 4. So for the fifth numerator for the fifth term is 5 plus 1, which is 6. And this is 6 plus 1, which is 7. And this is 7 plus 1, which is 8. And so the numerator for the 8th term R is 8 plus 1, which is equal to 9. And for the denominator, in order to get the preceding denominator 5, we add 2 to the preceding denominator. And so in order to find the denominator for the fifth term, we add 2 to 9, then we get 11. If we add 2 to 11, we get 13. And add 2 again, we get 15. And add 2 again, we get 17. So the value of R is equal to 9 over 17. For sequence S, we can see that they are all square number. For instance, 4 equals to 2 square, 9 equals to 3 square. When we move down the sequence, the base, the value of the base is added by 1, but the value of the power remains the same, where it is always a square number. So here we can predict that it is actually equals to 4 square, and 5, 4 plus 1 is equals to 5, so it is 5 square. And for the fifth term in sequence S, it should be 5 plus 1, which is 6 square, and this is 7 square, 8 square, and thus the value of s is 9 squared, which is equal to 81. For sequence t, we can see that all these numbers, they are multiples of 3. For instance, if we times 3, if we multiply the first term by 3, we get the second term. When we multiply the second term by 3, we get the third term, and so on. So, the value for the fifth term should be the product of 27 and 3. And for the sixth term, it should be 27 times 3 and times 3. And for the seventh term, 27 times 3 times 3 times 3. And for the eighth term, the value of t should be 27 times 3 times 3 times 3 and times 3, where the value is equals to 2187. For sequence U, it seems like it is not a proper sequence, but when we compare the value of sequence U with sequence S and sequence T, then we can figure out the pattern. For example, the first term in sequence U is equals to 3, and 3 is equals to the difference of the first term for sequence S and sequence T. So 3 is equals to 4 minus 1. 4 minus 1. Let's check whether our prediction is valid or not. 6 is equals to 9 minus 3, and 7 is equals to 16 minus 9. So in order to find the value for U, then we need to find the difference of S and T. So the difference of S and T is 81 minus 2187, where the value is equals to negative 2106. Part B. Find the end term of sequence PQRS, T, and U. For sequence P, when we analyze it, we can see that the common difference between two adjacent terms is negative 2. So, P is a linear sequence, where the general equation for linear sequence is A plus n minus 1 times the common difference. The first term for sequence P is 7. So A equals to 7 plus n remain minus 1, and the common difference is negative 2. So we times negative 2. Expand and simplify, we get 7 minus 2n plus 2, which is equals to 9 minus 2n. So the value for P, the n term for P is 9 minus 2n. Minus 2n. For sequence Q, all terms are cube number. 1 is equals to 1 cubed. 8 is equals to 2 cubed. 27 is equals to 3 cubed. When we move down the sequence, we can see that the index or the power remain the same, where it is always 3. So we can predict that Q must be the cube of certain number. And when we look at the base of the cube number, we can see that the base is always equals to the corresponding n number. So we can predict that for n term, the base should be n, and thus the n term for Q is n cubed. N cubed. For sequence R, numerator is a linear sequence where the value of A is 2 and the common difference is 1. So the n term for the numerator is 2 plus n minus 1 times 1. We expand and simplify, then we get 2 plus n minus 1, where it is equals to 1 plus n. So the numerator for the n term should be 1 plus n. For the denominator, yes, now let's work out the denominator. The denominator is also a linear sequence where the first term is equals to 3. So 3 plus n minus 1, and the common difference is positive 2. We expand and simplify this, we get 3 plus 2n minus 2. So it is equals to 1 plus 2n. So the numerator for the n term of R is 1 plus 2n. Sequence S. All terms in sequence S are square number. 4 is equals to 2 square, 9 is equals to 3 square, 16 is equals to 4 square. So we can predict that the power for sequence S for the n term should be a square number as well. Now we need to work out the index. We need to work out the base of the square number. If you look at the base for the first term, is 2, which is 1 more than the n number for the first term. The base for the second term is 3, which is 1 more than the n number. So from here, we can conclude that the base for the n term should be 1 more than the n number of the n term, which is equals to n plus 1. So the n term for S is the square of n plus 1. For sequence T, they are all multiples of 3. When we multiply 1 by 3, we get the subsequent term. So, or else, we can look at it in this way. 1 is actually equals to 3 to the power of 0. 3 is equals to 3 to the power of 1. 9 is 3 to the power of 2. When we observe this, we can see that the base of the sequence T is always 2. It's always 3. So we can predict that for the n term also the base will be 3, and the value of the index is always 1 less than the n number. For instance, when the power is 0, it is 1 less than 1. And for the second term, the power is 2, the power is 1, which is 1 less than the n number 2. So from here we can conclude that for the n term, the power should be 1 less than n, which is equals to n minus 1. And like what we have discussed just now, sequence U to be found by finding the difference of sequence S and sequence T. So for the n term of sequence U, it should be the difference between the n term of sequence S and sequence U as well. So the difference for n term of S and T is n plus 1 square minus 3 to the power of n minus 1. Part C. Which term in sequence P is equal to negative 7, 7, 7? Let's look at the n term for sequence P. It is equals to 9 minus 2n. So the n term is 9 minus 2n. In order to find the number of sequence for the term with the value of negative 777, we plug in the value here. Negative 777 is equals to the term, and it should be equals to 9 minus 2n. So when we solve this equation, we get negative 777 negative 9 is equals to negative 2n. So negative 786 equals to negative 2n. So that n is equals to negative 786 divided by negative 2, which is equals to 393. It means that the value for 393rd term is equals to negative 777. So the answer for part C is 393. Which term in sequence T is equals to 177,147? The n term for sequence T is 3 to the power of n minus 1. So 3 to the power of n minus 1 equals to 1777147. In order to work out the value of the index or the power, we can multiply 1777147 by 3, and we keep doing this until we get 1777147. If we divide this by 3, we get 59049. If we divide this number by 9, we get 6561. We divide by 9 again, we get 729. We divide by 9 again, we get 81. And we divide by 9 again, we get 9. And we divide by 9 again, we get 1. So which means that 177,147 is equals to the product of all these numbers. So this is equal to 3 times 9 times 9 times 9 times 9 times 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Which is equal to 3 times 3 square times 3 square times 3 square times 3 square times 3 square. 2, 3, 4, 5. So here we have 3 times 2, 4, 6, 8, 10 plus 1 is equal to 11, which means that 3 to the power of 11 is equal to 3 to the power of n minus 1. So 11 is equals to n minus 1. So the value for n is 11 plus 1, which is equals to 12. So the answer is equals to 12.